Alright guys, the one thing we did not get a chance to talk about with fluids is something called Pascal's principle. And Pascal's principle says that an external pressure applied to a fluid that is enclosed is transmitted unchanged throughout the fluid. Now that sounds very complicated, but all it really means is this. Let's say you took a sealed container like a Coke bottle. Okay, so you take a Coke bottle and you twist the top on real tight so it's airtight. Okay, if you squeeze that Coke bottle, you increase the pressure of the air that's left inside that Coke bottle. Okay, let's say it's empty except for air. Then what happens if you squeeze hard enough to create a pressure of 2 atmospheres? That 2 atmospheres of pressure would be uniform throughout the entire bottle, which would mean the air inside the bottle would be pushing out on the inside of the bottle with a pressure of 2 atmospheres everywhere throughout, or about 200,000 pascals. Okay, so all it's saying is we apply a pressure to a sealed container full of fluid. That pressure is applied evenly throughout. So this idea becomes really important when we're using a device called a hydraulic lift. And a hydraulic lift looks about like this. So the whole idea behind the hydraulic lift is we have kind of a system of 2 pipes. And we push down on a piston top that's on top of the smaller, thinner pipe. And that creates a pressure inside my enclosed fluid. That pressure is distributed throughout the fluid, including on this piston top that's over here. And so the pressure that I push down with over here is also the pressure that's exerted upward on the lift side over there. And those 2 pressures will be the same. Now, because force equals pressure times area, if the area over here A1 is different than the area over here A2, then the force over here F1 will be different than the force over here F2. And so that's the whole idea behind a hydraulic lift. So let's talk about how those work. So the whole idea there is that the pressure on P1, the side we're pushing down on, has to equal the pressure P2 on the lift side. And of course pressure is force over area. So the force that you push down on the lift side divided by the area of the piston on the lift side has to equal the upward force exerted on the lift side divided by the area on the lift side. Okay, so this side is the side we're pushing down on. And because we push down on one side, that causes the other side to lift. Okay, so let's look at an example problem. Okay, so for this problem we have a car that has a weight of 14,500 newtons. And we're lifting it with a hydraulic lift, and the piston that's lifting the car has a radius of 17 centimeters. And the side that we're pushing down on in order to lift the car has a radius of 4 centimeters. And we want to know how hard do we have to push down on the 4 centimeter side in order to lift the car, which is on the 17 centimeter side. So F1 then is what we're solving for. And A1, of course, is going to be pi R1 squared. F2 has to be 14,500 newtons in order to lift our car. And A2 is going to be pi R2 squared. Okay? And of course R1 was our 4 centimeters and R2 is our 17 centimeters. So your one homework problem you have to put into the Google form is to solve for F1. And we'll go over that tomorrow. And I'll see you then.